name is Sharon. Today I'll be discussing about Spectre and MELTDOWN, two major vulnerabilities that affect modern CPUs. These vulnerabilities expose sensitive data and pose serious risk to personal computers. Let's begin by understanding how these issues arise in modern CPU architecture. So, Spectre and MELTDOWN are critical security flaws that exploit weakness in CPU design. These vulnerabilities allow attackers to steal sensitive information from different devices, including personal computers, cloud servers, and mobile devices. Given their widespread impact, understanding how they work is critical for developing effective security measures. So let's understand about the background of CPU architecture. So modern processors use techniques like speculative execution and caching to improve performance. Speculative execution allows the CPU to anticipate and execute future instructions, while caching mechanisms store frequently accessed data to speed up processing. However, these optimizations create security loopholes that attackers can exploit to gain unauthorized access to sensitive data. So, let's understand what is meltdown. What is it? So, meltdown is identified as a CVE given number bypasses the fundamental security isolations between applications and operating system. It allows unauthorized access to protected kernel memory, which contains sensitive information like passwords and encryption keys. Meltdown primarily affects internal processors and some ARM-based CPUs, making some of the million of devices vulnerable to attacks. So now let's understand what is Spectre. Spectre is associated with the CVE numbers that is given in the slide that manipulates a CPU's branch prediction mechanisms. This allows attackers to trick programs into revealing data that should remain hidden. So, unlike Meltdown, Spectre affects a wider range of processors, including those from Intel, AMD, and ARM. Its broad impact makes it more challenging to mitigate. So, how do these vulnerabilities work? Both vulnerabilities exploit CPU optimizations. The process unfolds in three steps. That is, step 1, the CPU speculatively executes instructions assuming they might be needed. Step 2, data stored in cache. That means this speculative execution stores data in the caching temporarily. Step 3, attackers exploit cache. It means attackers can use cache side channel techniques to extract sensitive information. Because of these attacks don't leave traditional traces, detecting them is extremely difficult. Beside is the image that has been showing how the working process has been taken place. Coming to the next slide, it is potential impact. That means the consequences of Spectre and Meltdown are severe. These vulnerabilities can lead to various impacts, such as theft of passwords and login credentials, exposure of encryption keys, unauthorized access to confidential files and communication. Additionally, we can see some of the cloud services providers are at high risk, as attackers can potentially steal data from shared environments. Coming to the next, it is mitigation techniques. So, to encounter these vulnerabilities, various mitigation strategies have been implemented. Some of them are software patches. That means operating systems and applications have received updates to block these attacks. The second one is microcode updates. It means CPU manufacturers have released firmware updates to reduce risk. Coming to the third one, it is application hardening. Developers have modified software to minimize exploitation chances. So this is the graphical representation. So however, some of these mitigation techniques result in slower systems performance as well. Coming to the next slide, industry response. Some of the major tech companies and CPU vendors have taken swift actions on this, such as Intel, AMD, and ARM have released firmware updates. Operating system vendors have applied security features as well, and security researchers continue to monitor and develop new defenses. We can see there are three major divisions, that is CPU vendors, tech companies, and researchers. Despite of these efforts, new variants of Spectre and Meltdown continue to emerge, requiring ongoing vigilance. So, coming to the future consideration, we have to look forward, like what the industry must focus on and how we can defend such type of attacks or prevent. The industry must be focused on various, some of the we can mention here is proactive security. It means designing CPUs with a security as a priority. Second one, hardware software collaboration, ensuring that security features are built into both hardware and software. The third, continuous monitoring. It says that staying ahead of emerging threats to prevent similar vulnerabilities in the future. It must be monitored continuously. As CPUs continue to evolve, balancing performance and security will remain a key challenge. So at last, coming to, we can say Spectre and Meltdown highlights the security risks associated with CPU optimizations. Addressing these vulnerabilities requires a collaborative effort between the hardware and software vendors, we can say. The cybersecurity community must remain vigilant and proactive in defending against future threats. So, from security researchers and industry professionals, it is paramount, and we can say we have to continuously monitor and defend such type of similar attacks in the future. Thank you.